Okay, good evening, everyone. Today's class, I first go over the final exam questions. You should submit by May 3rd, midnight, like 11:59 p.m. So it has two questions and several sub questions. So let me start with the first question. So in the first question, uh, you need to analyze the transportation plan. So basically, first of all, they already have their own factory, and as you see in the write-ups, okay. So total transportation cost is $16,000. So they want to see with this new proposal, which new proposal means they are going to make three facilities: Albany, Hartford, and New York, and three warehouses in Worcester, Nassau, and Hartford. If the total transportation cost is less than 16,000, so it makes sense to make such a facilities. Otherwise, it doesn't make sense because they have some construction costs, and on top of that, they are investing in the construction. They want to have less transportation costs. Otherwise, it doesn't make sense at all. So, as you see, supply capacity in Albany is 210, in Hartford is 340, and in New York is 180. And negative signs means supply, positive sign means demand. So in Manchester, New Hampshire, the demand is 140, Boston is 280, and in Providence is 180. Three warehouses in Worcester, Nassau, and Hartford. So as you see, the transportation cost from Hartford to Hartford is zero because there's no transportation cost. Basically, in the Hartford, they can have a new warehouse there, so exactly in the manufacturing plant. So therefore, there is no transportation cost because there is no need to transfer the goods. They can just store it in the same place. And also, you can send some product from Worcester to Nassau too. So there's a link between two of the warehouses. So what need to do, first of all, you need to model it either in the Excel or Lingo. I didn't say Lingo in your exam, but if you can solve it in Lingo, that's fine too. And you need to say, this is in the first part of the question, you need to just make a cost benefit and say that, cost benefit analysis and see if this new transportation plan makes sense or not. Basically, is it if you minimize the transportation cost, because you can make a linear programming and you can assign how many goods you should send in each link. At the end, you can minimize your cost. So if the minimum cost of the transportation in this transportation plan is less than $16,000, it makes sense. So does anyone has question about the first part? I think the first was totally makes sense as very straightforward. But as you see, just have 5 points. There's 10 points in the second part. What is the second part? If you are allowed to add 100 to the capacity of one of the warehouses, which one you choose? What happens if you choose other warehouses? So you have 3 warehouses. You can either add in the Hartford, Nassau, or Worcester. You should say which one makes more sense. Which one minimize your cost at the end. So which one has if you minimize the transportation plan, so if you minimize the cost in each scenarios, which one is better? Basically in the part 2, you have three options. You eat Hartford, Nash, or Worcester. You should say adding 100 to which of them has more benefits. And you should say about the benefits. Maybe it doesn't change anything. Maybe at the end your answer won't be changed. That's fine too. Maybe you at the end in the part 2, you would tell me that it doesn't matter, you add 100 units to each of them. At the end the cost is same. So that's totally fine too. How you can say that, you should provide numeric evidences. For example, talking about the binding constraint, or talking about the final answer. So what happens if you add 100 to Hartford, to the capacity of Hartford, how it changes your final answer, or how, if you add 100 to the capacity of Nasha, what happens to the final answer? Maybe you have to solve the transportation plan 3 times. So just keep in mind, in part 2, answer is not just one line. Maybe don't say, okay, I think we should add to the Hartford because it's this. You need to solve it, and you provide numerical evidences. Any question about part 2?
Professor, in part 1,
Mm-hmm.
you were saying that it is 5 points. So we need to solve it and we need to give the number of, like, we need to minimize it
Yes.
and we need to give the result. That's it, right? We don't have to put any kind of long explanation. No, right?
Yes. Yes. At the end I said why you should compare with the 16,000.
Right.
Maybe you just write one sentence. That's
Okay.
fine.
Okay. Yeah, thank you.
Any other questions about uh, both parts of this problem? So if there is no questions about this problem, let me go to the second problem. So half of your credit comes from this problem. So let me read it. For daily trade in the stock market, you need to know the price movement. Price movement means if the stock price of a company goes up or down in the next day. For a case study, you just want to trade Apple stock. A data set provided as attachment of the exam. So I give you 2 other attachments. Download the attached data set and then do the following. Make 4 visualization, either figures or table in Tableau. So I just want to see if you can make some visualization or figures, tables, anything Tableau. I just want to see if you know Tableau. So it's on your own, but please mix some visualizations that make sense, some not very unrelevant, something relevant, but you are very flexible in terms of which figures or tables you want to use. You just need to describe something about your data. So let me open the 2 files. The first one is data dictionary. On the left side, you see variable names, ID, date, DGI open. So, but what does DGI opens? DGI means Dow Jones Industrial Average opening price. So, it might be very might be very related to finance, but basically you don't even need to know what those variable means. You can Google what does Dow Jones Industrial Average means and get some feedback, but for answering this problem, you don't need to exactly know what what does it mean. But basically, as you see, the first like um, 12 variables are related to Dow Jones. It's just average of some companies' stock prices and stock volume in the market. So as you see, Dow Jones high means uh, high price, low means low price, close volume. How many stock was that? Adjusted price. So these are, I think, could be straightforward. Look at the row 10. I said DJI Open Diff. Means DJI stands for Dow Jones Industrial Average. Open means open price. And differences means difference of the open price from today and yesterday. So there's two open prices. We just do the differences of them and you see the differences. So again, the next one is DJI Open SMA3 move. So DJI means Dow Jones Industrial Average, Open means open price. SMA stands for simple moving average. 3 is for 3 days and move. So what does it mean? So basically, DJI Open SMA 3 means simple moving average of DJI open price in last 3 days. 3 means last 3 days, and move. Move means the differences. Again, movement. Is it a decrease or increase, or is it up or down? So I look at two different 3 days moving average and see if the second one is more than the first one, is a up movement. If the second one less than the first one, is a down movement. So whenever you see move, the end of a variable, and this is a categorical variable which talking about the movement, which is the just seeing if it's a decrease or increase. So it's just at two classes, either increasing or decreasing. Like EMA, it stands for exponential moving average, and 3 means 3 days. And also you see for 5 days. And also there is other variables regarding the stock. These are just a stock value of Apple. Same as Dow Jones or DJI, we have high, low, close, total volume, and adjusted price. Also, there is some synthesized variables like differences of open price from yesterday and today, simple moving average, exponential moving average, and movement or just a continuous variable. The last independent variable actually is oil open, which means oil opening price. There is the oil market that has like open price, close price, so on and so forth. And the last one is our dependent variable. It's the one that we want to predict. As you see, stock open means this is Apple stock, open price, and we are looking the movement. So is it like is it going to increase or decrease? So again, since there's a move at the end of the variable name, it means this is a categorical variable. It's talking about is it the up movement or down movement. For example, you train a model, and it could be very practical. So let's say tomorrow you are going to buy, you want to decide if you want to buy a stock or not. If your model tells you that tomorrow would be an increase in the open price, you don't sell it today, because tomorrow it will be more expensive. But what if your model said tomorrow it will be a decrease in the open price? So you're more interested to sell your stock today because tomorrow you probably lose some money. As you see, it could be very practical. Actually, the data is real, and I got it from one of my researchers. If you're interested later, I can share the codes and data with you. But let's look at the second column. As you see, I said categorical and numerical. So a variable is either could be categorical or numerical or other variables like date and ID. So for date and ID, you see that I put no for both numerical and categorical variable. So let's say for Dow Jones Open, I said under categorical variable, I said no. For numerical variable, I said yes, because it's just a continuous variable. If there is any same until variables that has move. If it's move, as you see under categorical column, or yes, but numerical, no. And even same for your dependent variable. And the last column, I just said, is it dependent variable or not? As you see, all of them are independent except for, yes, except for the last variable, which is stock open move or opening movement of a stock price. Let me show you the data. So as you see, under ID, you have the ID number, under date, you have dates. For the variable that are numerical or continuous, as you see, you have a continuous number like 2000, something like that, 41. For the variable that has the move at the end of the name, it's 10. 1 means increase, 0 means decrease. So instead of putting up or down or decrease and increase, I put 0, 1, but it doesn't mean 0, 1. It just means 1 means increase. In the movement is like, is a decrease in, is it increase movement or decrease movement? So it's the reason you see 0 and 1. Even same for your dependent variable, which is a stock open move. But for this one, it's 1 and 2. 1 and 2, there's no difference between 1 and 0 and 1 and 2. It just means two different categories. So is it increase or decrease? So don't be confused that for almost all of the movement is 0 and 1. It just means two classes of increase and decrease. For even a stock open move, which is your dependent variable, you just have two categories, 1 and 2. Is it decrease or increase? So when you do modeling in KNIME or Python, you need to define which variable are numerical, which one is categorical, except for the last variable. So you don't need to, you shouldn't define the type of your stock open move, just let as it is. But for other variables, when you're using your KNIME or Python, you need to define the type. So you need to see which module define the types. Otherwise, KNIME would mess up. For the last one, that's fine because dependent variable should be always numerical. So the reason I'm saying that don't define the last one, because KNIME or Python could understand this is a numerical variable. For other variables, you need to tell KNIME or Python which one is numerical, which one is categorical. Otherwise, your model would be messed up. Any questions about the variables? So again, as a summary, when you see move at the end of the variable name, it means this is a categorical variable. Also, you need to tell KNIME which one is categorical, which one is numerical, but your dependent variable should be always numerical. Or maybe you don't need to even change it because KNIME would, I'm pretty sure KNIME can understand the last variable. So for the second question of your final exam, you need to upload your KNIME or Python and Tableau files. I should run it. So when, I mean, it should be executable files. Because I want to evaluate your grades, I need to run your code and see the results. So same for the Tableau. So please just upload the file that I can execute. But also for Tableau, I want you to take a screenshot of your visualizations. They're either tables or figures, and attach in the Word document. So again, for visualization, just use Tableau. For modeling part, you either use KNIME or Python and predict the price movement, which is the last variable. And also, it should be executable, and at the end, I should see accuracy and sensitivity of your model. So when I open your KNIME, it should be somewhere that I see your accuracy and sensitivity. So for this final exam, so for the first part, you need to upload your Excel file or Lingo file, and you need to write a little bit of explanation. For part one, the explanation is not a line, maybe just 1 or 2 sentences, but for part two, you need to explain a little bit about the plan and your proposal. As I said, I mean, and I also, even for two questions, maybe if you write your thought process, it's worthy because you and your friends might have different um, basically mindset and thought process, and I want to evaluate your thought process. But this is the minimum thing that I told you, but you can also provide more about your thinking process and put some more explanation so I easily understand what was in your mind and why you did such a model. For second part, I don't need explanation or write-ups from you. I just need to, first of all, be able to run your code. And also, when I run, I should see accuracy and sensitivity of your model because you're going to basically predict the movement. So I need to look at the predictive performance of your models. So any other questions about the exam? Okay, so I just want to see if there is any volunteer for presenting the projects in the class. If you are, so okay.
I want to present first.
Okay, that's good. So go ahead, please. So let me just stop my screen share and let you to share your screen. I think now you can share your screen if you want.
Yeah, this one. So my project is about Coral question pairs test. I'm Chen Hao. Quora is a question answer site where anyone can ask a question and get answers. Over 100 million people visit Quora every month, so it's not surprise that many people ask similar questions. multiple questions with the same intent can cause seekers to spend more time finding the best answers to their question, and also make the writers feel they need to answer multiple versions of the same question. My project is aimed at building a model to help Coral identify whether the given two questions are duplicated or not. In this way, a model with higher accuracy can save time for both seeker and writers. The dataset comes from cargo computation. I will use the text mining, deep learning, and natural language processing method to extract features from the questions and then stacking different classification models to get final accuracy. When I got the dataset, I realized that it was not an easy task. The dataset only has few columns, the ID for each observations, text for question 1, text for question 2, and their question ID. And at last, our dependent variable, whether it is duplicated or not, which is denoted by 1 and 0. The question pairs could be very tricky. We can take a quick look at the questions. Like in the first row, the question 1 is how can I lose weight loss, and question 2 is what is the best way to sustain weight loss. The question 1 asks about the way that can lose weight, and the question 2 asks about the best way, so it's not duplicated. And some questions share a lot of words but don't convey the same meaning. Like in the second row, the question 1 is when can I expect my cognizant confirmation mail, and the question 2 just ask when can I expect cognizant confirmation mail. They're just one word different. And what's more, some questions looks very different, but actually is duplicated. Like in the third row, the question 1 is what is the best book ever made, and the question 2 is what is the most important book you have ever read. So it's a pretty tricky task for me, for both me and the machine learning. The histogram on the top right shows the frequency of how many words in each question. We can see the most question has less than 20 words, but some questions are more than 200 words. And also in my data set, there are 63 questions pair express the different meaning. Only 37 questions are duplicated. It makes sense because most people ask different questions. The word cloud shows that shows what keyword people most the word cloud shows what keyword people most likely to ask. From the picture, the people always want to seek the solution for the best, like they ask the best way and they ask the best book. Also, they also want to ask for the difference, like the difference for any other things. There's a country comes out of all the countries that people are most curious about. It is India, and people also ask a lot about Donald Trump and Hillary Clinton. And then here comes the methodology part. The first challenge of my project is to extract features from the question text. First, I convert the text to vector by n-grams, TF-IDF, and pre-trained encoders. The n-grams and TF-IDF are very familiar. So, and the one of the basic pre-trained encoder is word of bag, where each word in the vocabulary is a dimension and the frequency of the word is the value in that dimension. But word of bag ignores the sentence structure because it excludes the function word like of. The sentence, the house is of stone, is completely different from the sentence, the house is stone. Because the sentence, the house is of stone, means the house is made of stone. What's more, the sentence that share many words might not convey the same meaning. Like the sentence, how are you? And the sentence, how old are you? They almost share all the words but convey different meanings. In this case, I use a better pre-trained encoder, universal sentence encoder, which overcome these two drawbacks. I can introduce it later if you are interested. After get the second vector, sentence vector, I calculate the cosine similarity and the vector distance as later input features. Besides the natural language processing feature, study also shows that deep learning method can extract features from the text. So basically, it first converts each question to the vector and then multiply the vector in one layer and output that layer as features. Another study shows that answer of questions could also significantly improve the performance. But in this project, I was not able to get that. I will talk about it later. Okay, after obtaining the features, I use stacking method to build my final model. The basic idea of stacking is to use the predicted result of basic models as new features to make the final prediction. So in my project, there are basically three stages. The first stage is to extract feature from the question text. First, I use the question one, question two to as input to put into the deep learning models and get the deep learning features. And I also use question one and question two to get those n-grams and TF-IDM, like the text mining features. And then I combine those the deep learning features and handmade traditional features as input to train my model. After get the predictions for each models, I use the prediction and these previous features as input to train the final model.
So I have a question here. You use supervised learning. What was your dependent variable?
A dependent variable is whether the two questions are duplicate, have the same meaning or not.
So how you got that dependent variable? Is it does it come from the database or you made by yourself?
Yeah, it's come from the database. It's
Okay.
the Coral, like the Coral customers who did that and make the data set.
Okay, so you have a column saying that this is it duplicated or not?
Yeah.
Okay, I see.
And this is the evaluation. I use the accuracy to evaluate the result by training model with only handmade features. Here, with only handmade features, we can see the light GBM and XGBoost has the highest accuracy. And random
So
forest.
just one more question. Again, could you explain what does handmade feature means?
Handmade feature is here like the traditional natural language processing features.
Okay, I see.
Yeah, because I made it by my hand. And compared to the handmade features, it's deep learning features, extract from deep learning models.
Okay, I see.
Okay. So with only handmade features, the light GBM and XGBoost has the highest performance, and random forest didn't perform well. And after I added the deep learning features, we can see almost all the models have similar output, and the random forest has the highest performance. We can see that the deep learning features increase the performance by increasing the prediction accuracy on one. The previous one is only 0.67, and after I add the deep learning features, it becomes 0.72. So one means duplicate question pairs, and those only consist of 37 observations. And actually, when I train the deep learning models, there's significant overfitting for my deep learning models, but I don't know how to tune in the parameters, like decide how many nodes in the hidden layer and how many layers I should add. If I can build a better deep learning model, the features extract from the model would have a higher quality, which can also increase the predicted accuracy, I think. And however, the final accuracy for the XGBoost is even lower by using stacking method. It might because the first tier of the stacking requires diverse model. However, the performance for my models are very close to each other. The train more models with different performance might help to get better results. So the conclusion was what I just mentioned about the deep learning features can improve the performance. The performance for my models are very close, which results in bad stacking results. Let's talk about the further improvement for my models. The study shows that answers can boost the predicted accuracy, because if I ask how old are you and what's your age, you can both answer you can both answer it by I'm 21 or I'm 24. But if I ask, how are you? You will answer, I'm fine. So the structure of the answer for similar questions are similar as well. And I was trying to use web crawler to get the answer of each question from the Coral website. But after I get around 100 answers from the Coral website, my IP address was banned from its server because I sent too many requests to their server within a very short time. So I'm not able to get the answer for the Coral questions. The second improvement will be tuning the model for the stacking so that the prediction accuracy of 1 and 0 for each question can be deserved. The last improvement is to tuning the deep learning models and train more deep learning models to get more and higher quality features. I believe after doing those, I can have higher accuracy for my models. That's it. Thank you.
Thank you very much. I really like your project. It was very good job. Thank you very much.
So do you have any questions?
I asked my question. Let's see if your friends have questions.
Okay, okay. Is there anyone have any questions?
So if there is no questions, is there any other one who is volunteer for presenting his or her project?
I think I can be the second one.
Okay, go ahead, please.
Okay, please wait a moment. Hi guys, today I introduce my topic about the Tesla stock price analysis. So this project was complete with the intention of helping Tesla stock investor better understand how to make decisions by training different models through historic stock price and social media data analysis. So initially, the intention for me is to check the predictor power of Elon Musk influence because, you know, he is my business hero. And then I do some research, you know, behavior economics shows that public emotions can profoundly affect individuals' behavior and decision making. So in order for investor utilize it, it is imperative for that business analytics to understand the behaviors and attitude of public within the finance context. So my project concentrated on trades and stock news. And I applied sentiment analysis and machine learning models, especially for XG boost to trades and news, which is extracted from Elon Musk tweets and Nasdaq news and New York Times news about Tesla. So usually there are three categories about news, you know, fundamental, technical, and sentiment. So it can be divided into positive and negative news. So I think only by understanding the values of public sentiment of this stock will investors be able to make great decisions. And also I conduct two models, ARIMA and long short-term memory in forecasting the stock price. And I compare these two results with prediction performance. And for my data set, you know, for stock market data, it is provided by Finance Yahoo, and it contains 7 columns. Example, open and close price.
So my question, did you download from your finance or the dataset was provided for you?
Yeah, I just download from the Finance Yahoo.
Okay, good, very good.
Yeah, and for tweets and news data, you know, Elon Musk's tweet from Kaggle, and it's between November 16, 2012 and September 29, 2017. But for for some Tesla news, I scrapped from New York Times and Nasdaq website. But I just scratched from headline and lead paragraph, and it takes so much time. And for data processing, I extract derive numerical features, for example, close to open ratio. And I also convert some headline to numerical word vector, and I use TF IDF. And I convert data to different data frame for future use. And at last, I merge data based on date. And here is a problem. So for Sunday or Saturdays data, the stock market is closed. So, but news is still exists, and I don't know how to deal with this. And for my methodology, I do some text mining for sentiment analysis, and I use ARIMA and a non-short-term memory, and I use XGBoost. And for parameter tuning, I use grid search in XGBoost, and I use IMSE for evaluation. And you can look at the screen, you can see the workflow of my analysis. For the tweets and the news analysis, first step is data collection, and then I do some sentiment analysis, and then I merge price analysis to find the correlation of sentiment and the price, and then I make the prediction. And for ARIMA forecasting, first I use, I first test the stationarity and test the seasonality, and I use add fuller test. And then I use log and differencing to remove the stationarity and seasonality. And then then I do some forecasting. And then I do some visualization. As you can see, investors depend on stock analysis to find the potential no profit stock. So maximum profit per share in a single day is about $28.09, and the change rate through that day is almost about 25.74%. So, and also, I say the price of stock has gone up, but the profit has highly been unstable for the middle part of the stock. And I also focus on some technical indicators, PE ratio. This is the common method to analysis a stock, and no PE ratio are favorable by investor. And I look for 7 years for PE ratio, and I can say, I make the conclusion that it's necessary to keep an eye on this stock to book profit. And you can see some keyword from work cloud. The top word cloud is from Elon Musk's tweets. You can see that Tesla and some good, some positive, so many positive words. And the other one is from New York Times. And it's just about headline and lead paragraph. And I also use Tableau to do some visualization. And you can see the red and the green, it's almost about the difference of low and high range and close and open range. I want this to show the stock movement. And I want to make a conclusion about my model, and you can see the 3 pair of graphics and the table I show in this slide. the IMSE of ARIMA is lower than RNN, and the ARIMA performs better than RNN. I don't know why, because I do some research that RNN is always perform better than ARIMA.
So my question, what did you put as a performance there? Is it accuracy or like error rate?
Error rate.
Okay.
And XGBoost has the best performance among all the algorithms. And the XGBoost better with sentiment analysis than without sentiment analysis.
I see.
Yeah.
So your best model was XGBoost with sentiment analysis.
Yeah.
Okay.
And for improvement, you know, I scrape news from New York Times with headline and lead paragraph. I think detailed body text can be tracked if for further prediction. Because my computer cannot scrape so much information. Maybe next time I can improve it. And also the Saturday and Sunday's information should be analysis, but I don't. In my project, I ignore the Saturday and Sunday's news. And for parameter, you know, I think my computer limitation of computational power, so maybe I can improve some parameter tuning. And finally, I think more algorithms can be tried in future studies. And I also do some related work. This is a reference. And that's all. Thank you.
Thank you very much. Good project.
If someone has questions?
So thank you very much. So is there anybody else who wants to present today? So it means we just have two presenters today. So, okay, I think it was it for today. Thank you very much. It was at first was very interesting semester for me, but it turned out to be very challenging for both me and you. And I'm sorry if there was some problems for your learning. It's, you know, it was a very tough semester. I think your grade at the end should be good one, because I'm pretty, from the project that you submitted, I think I saw very good feedbacks from you guys. And hopefully, I mean, last project is about the stock market. And if you look at the stock market today, we have a lot of improvement. It seems that, and people, I think we have one volunteer, but one more volunteer. So, but it seems they found some medicine for coronavirus. So I think it was the reason we see such a jump to the stock market today. So the next presenter is Fan Jiao. So please do the screen share and present your project.
Okay, please wait a minute. I
Sure.
will share my, okay. So, okay, Professor, can you see my screen?
Yeah, I see your screen.
Okay, I didn't use PowerPoint, I use Tableau, so yeah. So my project topic is COVID-19, and I focus on the COVID-19's effect on economy. So basically, I will only talk about the financial volatility index. For the introduction part, we all know now the devastation wrought by the COVID-19 outbreak is evident not only in the well-known global cases map produced by Johns Hopkins University, and it's also displayed in the downward pointing lines from stock markets around the world. So recently, some scholars already use simple linear regression model to explore the relationship between increased cases of COVID-19 and the financial volatility by involving the role of economic policy uncertainty. And so based on these researches in this model, in this project, I will use new index, which is Google Trend, to build models and to explain the effect of new cases of infection on financial volatility index. So basically, I used a SIR model to predict US daily new confirmed cases in May, and use the predict results to forecast the variation of VIX. So the purpose of the project is to explain the effect of COVID-19 on volatility index and to predict the variation of VIX in May. So yeah. The methodology part first is to preparing the data, and I did the data format, uniformation, and fill the missing value with median and fill the outliers with median, create new variables, which is increased cases based on the confirmed cases, and I convert the daily increased cases into logarithm format because basically it has the trending, so which is not friendly for the model training. And then is the model training, and I did linear regression first because it's easier to explain the relationship between variables. And then I use SIR model to predict the new confirmed cases, and then to use the result to forecast the variation of VIX. So specifically, I will explain what is SIR model. It is the epidemic model which computes the theoretical number of people infected with contagious illness in a fixed population over time. And it divides population into three parts. First is the susceptible people, and the second is the people infected, and the third is the people who have recovered. And all the three parameters vary as a function of time. So also after the SIR model, I use nearest neighbors and the decision tree, random forest support vector machine piecewise polynomial regression to predict VIX. And there is the visualization for COVID-19 across the world. So in the central linear plot is the confirmed cases plot. So we can see there is a dramatic increase after March, and my data is updated until April 25. So yeah, so up to April 25, there is over 2 million confirmed cases and over 2,000 death cases. And we also can see from this map, before March, China is the outbreak area, but it spread very quickly. And my interest area is United States. So basically, I use the economic policy uncertainty index is also come from the US area. So we can see New York is the most serious area with cases over 200,000 cases. So, and the death rate is 7.8%. And we can see from this central plot, these increased cases is kind of like they are in the same reason with the Google trend. And we can see from this plot, the blue line is the increased cases of global scale, and the bar is from the increased cases of United States. So we can see since March 17th, United has caused the most of the increase. And we can also see from the scatter plot, and where X and Google Trend has linear relationship, and also where X and the logarithm increase format has the linear relationship before 8. Yeah, and there is the modeling results. For the linear results, there is the coefficient of linear model is 2.7, which means unit increase in the logarithm increase variables will cause 2.7 increase in Vix. And for the piece linear model, we can see we have one break node. So when X is less than 7.8, the coefficient is 7.75, and when X greater than 7.8, the coefficient is negative 11.6. So we can see before 7.8, the logarithm increase cases. When logarithm increase cases increasing, the Vix will increase, but after 7.8, it then will have the then will decrease when the X increase. So for the red part is the SIR model result, and we can see the origin line is the predict result, and we can see this up to May 25. There will be confirmed cases over 1 million. So yeah, and there is the MSC for the different models, and the piecewise polynomial models has the least MSC. So I choose 3 of them to do the prediction. And the left part is the piecewise polynomial regression, which looks fit well. And the right part is the prediction linear plot with the true Vix value. So from this plot, we can see the piecewise polynomial did a good job, and it like then have almost overlap with each other. So after April 27, there the blue line, the extension part is the prediction value. Okay. And so for the suggestion for future study is, I think it will better to add some variables or factor to modify the effect of quarantine and keep social distance. So, and which will make the model more precise. And also, I didn't add the death rate as the predictors because the time limits, and I think it would be better to maybe add the death rate as one of the predictors. So yeah, that's all. Thank you.
Thank you very much. Very, very good topic. It's very relevant to today's issue, and good job. Thank you.
Thank you.
Okay, is there anyone else who wants to present? So I just wait like a couple of minutes. I don't want to miss any of you who are volunteer to present. Then see. I think Geo was the last one. Okay, again, thank you very much. It was a really good semester. It got very challenging at the second half of the semester. Hopefully, from next fall, we got back to the normal situation. But I hope all of you, I see all of you soon, very healthy and happy, and we just get back to the learning together very soon. Again, thank you very much. I really miss all of you. Hopefully, see you soon. Thank you very much. Have a great evening.
Thank you, Professor.
Thank you.
Thank you.
Thank you.
Thanks.